Topic is single phase full bridge inverter with RLC load for overdamped condition and underdamped condition. So this is the basic diagram of single phase bridge inverter with RLC load for overdamped condition and underdamped condition. Operation is similar like a RL load, okay, but here additionally one more element will be added for load. That one is a capacitance. So here at load condition we are taking RLC load, okay. So remaining all T1 T2 thyristors and T3 and T4 thyristors and D1 D2 D3 D4 diodes are common, okay. Here whenever one pair of thyristors are in conduction mode, and same like if any case all thyristors are turn off condition, then the damping current will be flowing through diodes. So D1 D2 D3 D4 diodes. When T1 and T2 in turn on condition and remaining all switches are in turn off condition, and when T1 and T2 in turn off condition, then immediately D3 D4 will be going to turn on it. Then D3 D4 will be going to turn off it. Then T3 and T4 will be going to turn on it, and T3 T4 will be going to turn off it. Then D1 D2 will be going to turn on, okay. These is the four modes of operation. Then we'll be going to discuss a few more points about this one. So this theory is the same like a RL load, okay. The difference is only four mode of operation will be going to change. So it's mean in that also we have to add RLC. So it's mean capacitance will be added in a four mode of operation, but these basic points are same for RL load and as well as RLC. So we have to learn RL load, then it will be going to easy to write these points in RLC also, okay. The main drawback of half bridge inverter is that is required 3-wire DC supply. This difficulty can however overcome by use of a full bridge inverter. It consists of 4 SCRs and 4 diodes. So already we know that 4 SCRs and 4 diodes, okay, here. And the amplitude of output voltage is doubled, whereas output power is 4 times in this inverter as compared to their corresponding in the half bridge inverter. For full bridge inverter, when T1 and T2 conduct, load voltage is Vs, and when T3 and T4 conduct, load voltage is minus Vs. So for a positive half cycle, if any case T1 T2 in conducting mode, we can get Vs. So that voltage is completely reverse for the T3 T4 in conduction mode. That's why we are taking minus Vs, okay. So reverse direction. So it's mean reverse direction in the sense both voltages are in opposite connections. So frequency of output voltage can be controlled by varying the periodic time t. During the inverter operation, it should be ensured that 2 SCRs in the same branch such as T1, T2 as shown in figure do not conduct simultaneously, as this would load to a direct short circuit of the source. For a resistive load current I0 and load voltage V0 would always be in phase with each other. When the load is other than resistive load, so it's mean RL or otherwise RLC, for such type of loads, current I0 will not be in phase with voltage VO, and when thyristors are turned off, diodes connected in anti-parallel, the energy is fed back to the DC source. Here D1, D2, D3, D4 are feedback diodes. So in RLC load, 4 mode of operation. So this is also a little bit similar of RL load 4 mode of operation, but here we are taking RLC load, no? So that's why we can take both current and voltages. So it's mean our LC will be going to in a discharging condition. Okay, when T1 and T2 thyristors are in turn on condition and remaining all switches are in turn off condition during the time period T1 and T2. So already I said in RL full bridge inverter RL load also how we are taking this duration of time period for one full cycle completely from 0 to T. So that T1 cycle we can divide into 4 parts, T0 to T1 and T1 to T2 and T2 to T3 and T3 to T4. Up to T4 only the one full cycle of the bridge inverter. Okay, so here when T1 and T2 in turn on condition and the waveform, it's mean the output value will be created in the waveform from T1 duration to T2 duration, and the flow of current in positive half cycle, that one also in rising current, so from A to B through RLC load. So here you can observe this diagram. Here this one is a Vs voltage. So from Vs voltage to T1 thyristor in turn on condition, then the flow of current from A to B through RLC load. So when the flow of current through this load, the inductor and capacitor will be going to fully charge. So then only after that the remaining current will be flowing through T2 thyristor and it will be going to return back to the source voltage Vs. Okay, so when the current flowing through this load from A to B, the inductor and capacitor is in fully charged condition. This is the first mode of operation. And the second mode of operation, when T1 and T2 thyristors are in turn off condition, immediately D3 and D4 will get turn on, because of in RLC load both inductor and capacitor will not allow the sudden change of current. Already we know that inductor and capacitor functionalities are, it will not allow the sudden change of current, and that's why the damping current will be created. So that damping current flows through D3 and D4 during the time period T to T3. Next duration of time period is T3 to T4. Okay, so this is the basic diagram of mode 2. So whenever T1 and T2 in turn off condition, they may immediately D3 and D4 will be going to turn on it. Why? Because inductor and capacitor previous condition, mode 1, fully charged condition, when the power supply, it's mean T1 and T2 in turn off condition, immediately inductor and capacitor will create a damping current. So it's mean it will not allow the sudden change of current. Because of that, sudden change of current will be going through, flows through the diodes. So that's why polarities of this load will be going to change. It's mean from previously the flow of current from A to B, no, right now the flow of current from load to, it's mean inductor and capacitor will be going to discharge. That discharging current flowing through B to D3 and D3 to power supply Vs. So Vs to D4 and D4 to A to return back to the load. So this is the flow of current direction. So here the flow of current from B to A. So previously A to B, previous mode of operation, A to B. So that's why this one is in a negative half cycle. Okay, the flow of current in negative half cycle. Okay, you remember this one. Then next we will go for next mode 3 operation, when T3 and T4 in turn on condition and remaining all switches are in turn off condition. During the time period T3 and T4, the flow of current is in reverse direction of the previous flow of current. That's why here flow of current is a negative duration, negative rising current. So negative rising current means what? So whenever T1 and T2 and previously D3 and D4 in turn off condition, then immediately T3 and T4 will be going to turn on it. So in this condition, the flow of current from Vs to T3 and T3 to B and B to A and A to T4 and T4 to Vs. So previously first mode of operation, the flow of current from A to B. The flow of current at that time, inductor and capacitors are in fully charged condition. So that's why that one also a rising current. But here directly the source voltage flowing from T3 to B to A. This one, this condition also the inductor and capacitor in fully charged condition. So this current also a rising current. Okay, but the difference is the flow of current direction is completely different of mode 1 operation and mode 2 operation. Mode 3 operation. So mode 1 operation, the flow of current from A to B. So that one is one direction of flow of current. Right now in mode 3 operation, the flow of current also a rising current, but that current is in reverse direction from B to A. So that's why we are taking this one in a negative rising current. So both are rising current only. We can get peak voltages, maximum voltages, but mode 1 operation we can get a positive peak current, and here we are getting a negative peak current. So we will see in waveforms. Okay. Then when mode 4 operation, when T3 and T4 in turn off condition, immediately D1, D2 will be going to turn on it. So it's mean that time flow of current reverse from load to D2 and D2 to Vs and D1 to return back to the load. Due to inductor and capacitor sudden change of current current and voltages. Previously in RL load condition, we have written only inductor will not allow the sudden change of current. That's why we are taking it's mean damping current only for diode and D1 and D2. But here we are taking both current and voltages are not allowed. That's why the flow of current flows through D1 and D2 during the period T0 to T1. This current is a negative decay current. Okay, so this is the basic diagram of fourth mode operation when in a D1 and D2 in turn on condition. That's the case. So when previously in third mode of operation, inductor and capacitor are fully charged condition. When T3 and T4 in turn off condition, then immediately inductor and capacitor will start to discharge. So it's mean creating a damping current. So inductor and capacitor will not allow the sudden change of current. So that sudden change of current will not allow sudden change of current will be flowing through diodes. So here previously in mode 3, the flow of current from B to A. Right now the polarities are interchanged, plus and minus. So it will be going to start from load to A. So it's mean the flow of current from A to B. Okay, so A to load to A and A to D1 and D1 to source voltage Vs and Vs to D2 and D2 to B. So it's mean the meaning of this one is the flow of current from A to B. Okay, so this one also a completely reverse of previous mode of operation. So that's why here this flow of current flowing through a negative half cycle. So that one also a negative decay current. Okay, this is the fourth mode of operation. So already we know that what is the fundamental and the basic operation of a four mode of operation. We have seen in we have seen and we discussed in RL load the same similar way of operation here also in RLC load also, but the difference is only one difference. That one is capacitor will be added. Because of that, along with current and voltages also, I mean capacitor also will not allow the sudden change of voltage. That's it. Remaining everything is mode of operation is same like RL load only. Then we will go for waveforms. Output waveforms of RLC load for overdamped and underdamped condition. సో ఇది ఇన్వర్టర్ కాబట్టి ఆల్రెడీ మనకు తెలుసు ఇన్పుట్ వోల్టేజ్ మనం డీసీ ఇన్పుట్ వోల్టేజ్ తీసుకుంటాము. ఫస్ట్ మనం IG1 అండ్ IG2 అనేది టర్న్ ఆన్ చేయడం కోసం, అంటే ఐ మీన్ థైరిస్టర్ T1 అండ్ T2 టర్న్ ఆన్ చేయడం కోసం IG1 అండ్ IG2 గేట్ ఫైరింగ్ ఇస్తాము. అదే థైరిస్టర్ 3 అండ్ థైరిస్టర్ 4ని టర్న్ ఆన్ చేయడం కోసం మనం IG3 అండ్ IG4 గేట్ని ట్రిగర్ ఆన్ చేస్తాము. సో కాబట్టి ఇవి గేట్ యొక్క ట్రిగర్ ఆన్ కరెంట్ అనమాట యాక్చువల్గా. సో ఇది T1 అండ్ T2కి అండ్ T3 అండ్ T4 టర్న్ ఆన్ చేయడం కోసం మనం తీసుకున్నటువంటి గేట్ ఫైరింగ్ పల్స్ అనమాట. ఓకే, then when we are taking output voltage, that output voltage is equal to a input voltage, source voltage. So source voltage and output voltage is those two are equal when we are turn on T1 and T2 thyristors by using IG1 and IG2 gate pulse. Okay, then at a positive peak voltage, output voltage, when T3 and T4 in turn on condition, we are getting a negative peak voltage. That one is VO output voltage equal to minus Vs. So it's mean compared to these T1 and T2 in turn on condition, we are getting a reverse direction of flow of current. So it's mean we are giving a opposite power supply for a negative half cycle. So that's why we can get output voltage is completely opposite of this positive half cycle. That's why we can take VO equal to minus Vs. And similarly we can take alternatively, so positive half cycle and a negative half cycle. And same like similarly current output current also. For R load, purely resistive load, both voltage and currents are in phase only. That's why where we are getting a peak input voltage, the same place we can get peak current. Okay, for a positive half cycle when T1 and T2 thyristors are in turn on condition. When T3 and T4 in turn on condition, we can get negative peak. So same like current also we can get negative peak. So that's why I naught equal to minus I naught. So it's mean this one is in for one direction of flow of current. So oppositely we can get this negative peak current. Okay, and similarly alternatively. Okay, so this one is positive peak current and this one is negative peak current. For a purely resistive load, we are taking up to here only. If any case they will ask RL load, in the sense we are going to take this up to here only. So it's mean first input voltage and IG1 and IG2 current and IG3 and IG4 current for full wave rectifier, and output voltage and output current, and this one is RL load. Directly we have to take when T1 and T2 in the turn on condition, then immediately then it will be a rising current. Then when T1 and T2 in turn off condition, then immediately the damping current will be flowing through D3 and D4 current. So up to damping current, I mean inductor and capacitor fully discharged, then it will be going to reach to the 0. Then when T3 and T4 will be going to turn on, it's mean when D3 and D4 will be going to reach 0, then immediately T3 and T4 will be going to turn on, I mean a rising current. So in that rising current, that one is a negative peak rising current. So when T3 and T4 will be going to turn off, then the damping current will be flowing through D1 and D2. The same D1 and D2 will be going to turn on previous case T1 and T2 before, because here T1 and T2 before we had D1 and D2, no, the same thing here also, T1 and T2 before D1 and D2. Why? Because this one is D1 and D2, one full cycle is completed, then again one more cycle will be repeated. So that's why here D1 and D2 in turn on condition, because without any flow of current through the inductor and the capacitor, there is no any charging current in inductor. So when it will be a fully charged, then only it will be going to start to discharge. That discharge current only flowing through the diodes. So that's why first we can start with T1 and T2 turn on condition, then only it will be going to take D1 and D2. So here alternatively T1 and T2 and D3 and D4 and T3 and T4 and D1 and D2. Already we discussed in 4 modes of operation. When T1 and T2 in turn off condition, immediately T4 will be going to turn on, and T3 and T4 will be turned off. Then immediately D1 and D2 will be going to turn on. So T1 and T2 in turn on condition, that one also a rising current, but that rising current is a positive rising current. T3, T4 condition also a rising current, but that rising current is a negative peak rising current. And D1 and D2 in turn on condition, that one is a decaying current. That decaying current is negative decaying current. And D3 and D4 is in turn on condition, that one is a decaying current, but that decaying current is positive decaying current. First one is RLC overdamped condition. So this one is overdamped condition. In overdamped condition, XC is greater than XL. So capacitive reactance is high compared to inductive reactance. So this one is a overdamped condition. So in overdamped condition, what will happen? For a positive half cycle, we are getting a negative damping current, and for a negative half cycle, we are getting a positive damping current. So this is the actual phenomenon. You have to remember here. First, here D1 and D2, and when T1 and T2 in turn on condition, then up to here positive half cycle will be going to completed. But when T1 and T2 will be going to turn off it, then immediately D3 and D4 will be going to turn on it. So that D3 and D4 will be going for negative half cycle. Negative half cycle is half of negative half cycle here. That negative half cycle we can get it at positive half cycle side, D3 and D4. That's why only we can talk about this one is a overdamped condition. So underdamped condition in the sense, when it started for a positive half cycle, then it will be going to end for the same positive half cycle. You remember? So the positive half cycle started from here to here. So here only the end of that waveform. And mean T1 and T2 and D1 and D2, these two will be going to end for one positive half cycle. The same thing T3 and T4 and D3 and D4 will be ended for negative half cycle. For a positive half cycle, both diodes and thyristors will be turn on and turn off it in the sense. That one is underdamped condition. It's mean between underdamped in the sense between only one half cycle, and negative half cycle negative and positive half cycle positive. So here from here started negative half cycle, then ended negative half cycle here. Okay, so it's mean for positive half cycle those two are turn on and turn off it, and negative half cycle those two are in turn on and turn off it. So this is the underdamped condition. This is the overdamped condition. Okay, so overdamped condition in the sense it will be going to extend it for a positive half cycle, it will be going to extend for negative half cycle, and negative half cycle it will be going to extend it for positive half cycle. It's mean whenever it will be started a negative half cycle, okay, turn on it. So it's mean before T3 and T4 turn on it, then the damping current will be flowing through a D3 and D4. That D3 and D4 will be in negative half cycle, but that negative half cycle also we can execute it in the first half of the circle. Okay, this is the underdamped condition and overdamped condition. So if you have any doubt in confusion in the sense, I have drawn a very small waveform. If maybe a little bit observation is missing in the sense, it's mean you have any confusion in the sense, you have to once observe thumbnail waveform also, then you will be going to get one clearance in that waveform. Okay.